kilogram force.
Kilogram force, right? And 1 kilogram force is equal to G newtons or 9.8 newtons, whatever is the value of G given in that question. मास मिल गया हमें. Initially its speed is changing from 36 किलोमीटर पर आवर. ये शायद लास्ट क्लास में भी कर लिया था हमने. किलोमीटर पर आवर को मीटर पर सेकंड में चेंज करने के लिए we do multiply by 5/18. That become 10 meter per second. Final velocity is 72 kilometer per hour, which is 72 into 5/18, 20 meter per second. Final velocity 20, initial velocity 10, mass is given, time taken is 2 minutes. Shrey, we have to calculate work done. What is work energy theorem? Shrey, I'm asking you. Shrey?
Yes, sir.
What is work energy theorem? Give the statement and formula both.
W equals to half m v square minus u square.
यार statement ये लिखोगे W is equal to half m. What is the statement of work energy theorem?
So when a
Yes,
force is applied in the direction of motion,
Sir, work is equal to final kinetic energy minus initial kinetic energy.
I'm asking you statement, the definition. If you have to write, I think आपको शायद टेस्ट का वो मिल गया होगा. If not, then you will get. I think tomorrow, no, next Sunday. Next Sunday we are having a test of physics on work energy and power. Today we'll finish it. Next Sunday will be test of. तो उसमें आपको ना डिफिनेशंस भी लिखनी है. वर्क एनर्जी थ्योरम क्या था स्टेटमेंट तेजस्वी?
Yes, sir. It is the increase in kinetic energy of a moving body that is equal to work done by force acting in the direction of moving body.
The total work done by all the forces acting on a body is equal to change in its kinetic energy. The net work done by all the forces acting on a system is always equal to change in kinetic energy. Work done is equal to half m v square minus u square. Mass is 1000.
टेस्ट होगा.
हाँ बेटा.
अगले हफ्ते टेस्ट होगा.
Yes, अगले हफ्ते संडे को टेस्ट होगा. अभी आज और कल जो होगा वो वर्कशीट बेस्ड होगा. I will share your worksheet in the last 15 minutes. 2 worksheet each class. और हमने सर्कुलर मोशन का भी टेस्ट नहीं हुआ था, so that is also worksheet based test. Half mass is 1000, v is 20, and u is 10. Vihan is here or not? Vihan? हो गया क्या ये? Okay, I'm just calling him. Calculate question number 18, Mr. Shrey. Shrey, what is the answer?
sir, calculate करना.
Vihan is on another call. Thanks.
So 1,50,000.
हाँ मतलब उसको थोड़ा पावर में लिखोगे तो ज्यादा बेटर रहेगा. It will be 150. That means 1.5 into 10 to the power 5 joule. Second में हमें power calculate करना है. Power is work done upon time. Time is given as 2 minutes. Convert that into second. 1.5 10 to the power 5 divided by 2 into 60. Done? Right. Question number 18 हो गया. Question number 20. 20 किसका doubt है?
सर
20
मेरा
किसका doubt है? Okay. How much work is needed to be done on a ball of mass 50 gram? Mass of ball is 50 gram, and it says to give it a momentum of 5 kg per meter per second. So initially it is at rest, and finally it is acquiring some velocity, due to which it has the momentum of 5 kg meter per second. Tejasvi, what is the formula of kinetic energy in terms of momentum? There is one formula, half mv square. Another formula was there in terms of momentum. Kinetic energy in terms of momentum. Tejasvi,
Yes, sir.
kinetic energy in terms of momentum.
I don't know, sir.
I don't know, but I have.
Is it 1/2 into v square into m?
That's the kinetic energy half mv square that I have written. I'm asking in terms of momentum P.
सर
Shrey, what is the formula?
K equals to P square upon 2m.
P square upon 2m. Kinetic energy का formula P के terms में work done is final kinetic energy minus initial kinetic energy. So P square by 2m is final, initial is 0. P is given as 5 square upon 2. Mass is 50 gram, that you convert into kg. So that becomes 0.05. Yes, Kabir understood this. Initially it is not moving, so initially it is at rest. Now it has acquired momentum, so that means it has acquired kinetic energy. That change in kinetic energy is equal to work done. Final momentum, initial momentum is 0, final momentum is given. From final momentum we can calculate
सर 250 Q.
Sir, 250.
yes 250.
सर सॉरी मैं थोड़ा लेट हो गया बट अभी हम क्या कर रहे हैं
बेटा हम एक्सरसाइज 2A और 2B के डाउट्स कर रहे हैं. एक्सरसाइज 2A किसी को कोई डाउट नहीं था. 2B में जो डाउट्स थे, those are 18, 20, 21, 23. You were on another call. Question number 18 we discussed last class also. Question number 20 is related to the same topic. Work done is seen in kinetic energy, but kinetic energy calculate करने के लिए mass की जगह पे momentum given है. So in terms of momentum, the formula for kinetic energy is P square by 2m. Right? Okay. Next is question number 21. यार आपने कर ली exercise 2A, 2B, 2C. Yahan, you did your homework?
यस सर बट मैंने 2C नहीं करा
2C नहीं करा. Okay. कोई बात नहीं. 2C हम अभी करेंगे.
2C का वो कंजर्वेशन ऑफ एनर्जी हमने शुरू नहीं किया था.
Right. How much energy is gained by a box of mass 20 kg when a man carrying the box waits for 5 minutes for a bus? Okay. 21 किसका डाउट है? किसने पूछा 21? Shrey, it's your doubt?
सर
No,
मेरा
sir.
डाउट था.
अच्छा. So in the first part, when a man is having a box of 20 kg but is waiting there at the station at the stop. So since displacement is 0, work done will be 0 in the first part. Right? Second part, the runs carrying the box with a speed of 3 meter per second to catch the bus. Again, initially he was in a state of rest and finally he is moving with 3 meter per second. Use the work energy theorem.
सर इनिशियल वेलोसिटी तो जीरो होगी ना?
Initial velocity 0 होगी.
तो सर इधर हम सीधा 1/2 mv स्क्वायर भी तो कर सकते हैं, बस इनिशियल तो 0 ही है. पॉइंट क्या है
क्या?
इधर सर? जैसे इनिशियल वेलोसिटी 0 है, तो जो हमें फाइनल वेलोसिटी देगा वही तो मैटर करेगा. तो ये
सर आंसर 90 जूल्स आ रहा है.
तो ये v स्क्वायर करना है से v स्क्वायर माइनस u स्क्वायर करने से कोई पॉइंट नहीं है, सीधा v स्क्वायर ही कर देते हैं.
बेटा पहले तो पूरा फॉर्मूला लिखोगे ना. एग्जैक्ट फॉर्मूला क्या होता है वर्क एनर्जी थ्योरम का? वर्क डन इज चेंज इन काइनेटिक एनर्जी. So that you have to show in the exam. Mass is 20, V is 3 and U is 0.
हाँ सर, ओके.
तो 90 है.
90 है. Similarly, third part.
सर 100.
Raises the box by 0.5 meter in order to place it inside the bus. So when he raised the box to height of h, assuming that he applies the same work, same force as required by the gravity, against the gravity.
सर इसमें G10 दे रखा है तो आंसर आ रहा है 100.
तो हम 10 ले लेंगे. Right? Yes, this will be MGH. M is 20, G is 10, and H is 0.5. Say Jess, which part was it out?
सर मुझे समझ नहीं आ रहा था ये वाला क्वेश्चन, कैरिंग द बॉक्स विद स्पीड ऑफ 3 मीटर्स पर सेकंड, ये इसमें करना क्या था, ये नहीं समझ आ रहा था मेरे को.
ठीक है. So you can see that mostly it is the work energy theorem. Work energy theorem is the most useful method for finding the work done. Now question number 22 भी कर लेते हैं. 23 is the doubt. 22 no 20 21 22 doubt है किसी को?
No sir.
होना चाहिए था, नहीं है, अच्छी बात है. 23. The spring is kept compressed by a small trolley. So there is a spring which is already compressed by a trolley. A trolley is compressed the spring, let's say by X. The spring has energy stored, it is a force constant K. The elastic potential energy stored in the spring is half kx square. K is the spring constant or force constant. ठीक है, but इस फॉर्मूले की हमें यहाँ जरूरत नहीं. This is just I am revising. Elastic potential energy is half kx square. Now when this is released, the spring gets back to the normal initial position and this trolley acquires a speed of 2 meter per second. So by energy conservation, the loss in this is energy conservation or conservation of mechanical energy? What should we write? This is conservation of mechanical energy.
सर हम इसमें ये भी कर सकते हैं ना, काइनेटिक एनर्जी इफ वी फाइंड आउट विल बी द सेम एज द पोटेंशियल एनर्जी इन द फर्स्ट पोजीशन.
नहीं बेटा, ऐसा कोई लॉ नहीं है. You have to write loss of one type of energy is equal to gain in another. I mean, kinetic energy is equal to potential energy. No, there is no such law. Sum of kinetic plus potential is constant. That is the law of conservation of mechanical energy. Loss in potential energy will be equal to G. Potential energy loss is whatever. Initially it is half kx square, finally it is 0. Gain in kinetic energy, finally it is half mv square, initially it is 0. So we have to find this potential energy, half kx square, that will be equal to half, mass is 0.5 and the speed is 2 square. So that becomes 1 joule. Correct. Exercise 2b is done. Now exercise 2b was the conservation of mechanical energy principle. Now let's jump to exercise 2c. 2c is a conversion of energy and from the numerical section and the multiple choice. Vikramaditya. Vikramaditya. Okay.
सर हमने बस कन्वर्जन ऑफ एनर्जी किया था लास्ट, हमने कंजर्वेशन ऑफ एनर्जी नहीं किया था.
That is the conservation of energy. Energy cannot
Sir,
be created or destroyed. It can only be transferred from one form of energy to another. It can only be converted from one form to another. Yes, Shrey, कुछ कह रहे थे आप?
तो मुझे 2C में क्वेश्चन 5 and 6 में डाउट है.
2C तो हम स्टार्टिंग से कर रहे हैं, don't worry.
ओके सर.
2C we are doing from the beginning, so don't worry. Right? Yes, 2C the first question. First, the multiple choice. A ball of mass m is thrown vertically up with initial velocity u so as to reach height h. What will be answer to first question, Tejasvi? Multiple choice. Tejasvi,
Yes, I'm thinking.
a ball
सर
of
मैं
mass m
आंसर
is
कर सकता
thrown.
हूँ.
नहीं, एक second. Initial velocity u so that it reaches a height of h.
सर एक सेकेंड, मैंने पेज नंबर 46 खोला है जहाँ 2C शुरू हो रहा है. मल्टीपल चॉइस तो नहीं है मेरा.
Number 47, multiple choice.
अच्छा, ओके.
First question.
So answer is the potential energy of the ball at the highest point is mgh.
Potential energy at the ball at the highest position is
वो
mgh.
सबसे ऊपर है तब उसकी सबसे highest है.
Right. Okay. One answer is D. Kabir, what is the answer to second question? Kabir, the pendulum is oscillating on other side of its rest position. The correct statement is. Kabir.
Yes, sir.
यार बोला करो. I am asking answer to second question. The pendulum is oscillating. You have the book right now? You have the
Sir,
book
no,
right now?
not as of now, sir.
You don't have the Selena book?
Sir, I do have it, but right, not as of now.
हाँ, तो लेके आओ, हम क्वेश्चन कर रहे हैं साथ में फिर. Go
Okay,
and
sir.
check it. Okay, Mr. Shrey, what will be the answer to second question? Pendulum is oscillating on either side of its rest position. The correct statement is
The sum of its kinetic and potential energies remains constant throughout the motion.
right. The sum of kinetic and potential energy remains constant throughout the motion. When it is at the maximum height, all
Sir,
energy. Yes.
इसका रीजन ये है जो आपने अभी बताया कि लॉस इन पोटेंशियल एनर्जी विल बी इक्वल टू गेन इन काइनेटिक एनर्जी. That's why
The
it's
reason ये
constant.
है because there is no dissipative force. That was the condition required for conservation of mechanical energy. Conservation of mechanical energy is that if there is no dissipative forces इनकी वजह से energy heat के form में dissipate हो जाती है like friction. If there is no friction in the system, then the total sum of kinetic plus potential energy remains constant. This principle is called conservation of mechanical energy. Okay, let's do numerical. Say numerical first question. How do we do? First, the ball of mass 0.2 kg is thrown vertically upwards with initial velocity of 20 meter per second. Mass is 0.20 kg. Calculate the maximum potential energy. It goes as it goes up. Mr. Shay, question number 1.
Sir,
Concept.
40 joule.
Okay, what's the logic? वो तो आंसर में लिखा हुआ देख के बोल रहे हो.
The height equals to v square upon 2g, and
Okay.
the height is 20 meter, and PE equals to mg.
Okay. Okay, right. Otherwise, we could have used directly that the total kinetic energy at this point, lowest point, converts into the potential energy. So we don't need to calculate the height. We can directly apply the conservation of mechanical energy. Kinetic at A plus potential at A is equal to kinetic at B plus potential at B. A पे kinetic energy half mv square, potential energy 0 because that is the ground level. And when it is at the maximum height, its kinetic energy will be 0 because this comes at rest. Potential energy will be the maximum. Maximum height पे potential energy maximum होगी. Kinetic energy 0, so that maximum potential energy will be same as the kinetic energy given at the lowest point, half mv square. So you can directly just write, calculate half mv square and substitute that the same energy will be. So that's 40 joule. Mr. Vihan, second question. Exercise 2C, second question.
सर मैं आप एक बार क्वेश्चन पढ़ सकते हो मेरे लिए?
क्यों तुम्हारी बुक कहाँ है?
सर मेरी बुक मैं ना मेरे लैपटॉप में कोई प्रॉब्लम था तो मैं अपने घर पे नहीं हूँ, अभी कहीं और हूँ. और मैं ना जब सुबह गया था तो मैं अपनी
तो मैं
स्कूल
भेज देता हूँ यार, ऐसा है तो
मैं अभी अपनी टेक्स्ट बुक मंगवा रहा हूँ, अभी आ जाएगी. थोड़ी आप एक क्वेश्चन पढ़ सकते हो?
ये क्वेश्चन पढ़ना क्या है, फिर मैं भेज ही देता हूँ. Okay, I'm sending the question. उनके पास है, वो ट्राई करें. Okay, so yes, I have shared this remaining questions to your WhatsApp in the group. Question number 2, Mr. Vihan, it's your turn. विक्रमादित्य समझ आ रहा है बेटा क्वेश्चन? विक्रमादित्य got the questions in the group?
सर फाइनली सर मेरी फिजिक्स टेक्स्ट बुक आ गई, एक्सरसाइज 2C
Finally मेरी फिजिक्स टेक्स्ट बुक
आ गई, मैंने मंगवा दी है मेरे पास।
अभी तो नहीं थी 1 मिनट पहले।
सर मैंने कहा ना मैं कहीं और हूँ, मैंने अभी किसी से मंगवाई है अपने घर से।
लेके बैठा करो बेटा फिजिक्स क्लास के लिए, फिजिक्स क्लास का मटेरियल लेके बैठा करो। यस,
हाँ
2A. The question is, stone was 500 grams is thrown vertically upwards with a speed of 15 meter per second. Calculate the potential energy at the greatest height. Same as the previous question. जितनी हमने इसको बॉटम पे काइनेटिक एनर्जी दी है, the same will convert into potential energy.
सर हम काइनेटिक एनर्जी कैलकुलेट कर लेंगे तो फिर आ जाएगा ना?
हाँ बिल्कुल. Kinetic energy on reaching the ground is same and it says that total energy is halfway. So जितनी हमने इसको एनर्जी अभी काइनेटिक एनर्जी के फॉर्म में दी है, which is the second question, B part. Kinetic energy at the lowest point is half mv square. At the maximum height, the same kinetic energy converts into potential energy, and at any halfway through, the sum of kinetic plus potential energy always remain constant. Kinetic energy at point A, potential energy at point B, and at any point C in between, kinetic energy plus potential energy at C is constant, and it is same as the total energy given at the beginning. By conservation of mechanical energy, the total energy always remains constant. Question number 3. A metal ball of mass 2 kg is allowed to fall freely from rest of height 5 meters above the ground. Okay. Metal ball of mass 2 kg is allowed to fall freely. Kabir, you got this question in the WhatsApp group?
Yes, sir.
Kabir? Okay, so this is question for you. Initial velocity 0, it is dropped from a height of 5 meters. Taking G is equal to 10, find the potential energy possessed when it is initially at rest. Kabir, what will be the answer to first?
So 1 minute.
1 minute, so long.
So 100 joules.
No method, I mean, don't just give the answer. I want to check your thought process.
So you mean steps?
Yeah, steps, the logic, the concept. How did you get it as 100?
So you have to multiply, right? So multiply 2 into 5 into 10.
Question is asking the, okay, potential energy possessed when it's initially at rest. Okay, it is mgh, right?
Yes, sir. 2 into 5 into 10.
Yeah, so you have to just give me this formula that you have using. Second part, kinetic energy of the ball just before it hits the ground.
So I didn't get this one.
Initially, it has potential energy. As it comes down, the potential energy converts into kinetic energy. At point A, it has potential energy. At point B, the all potential energy converts into
Sir,
kinetic energy.
जब हमने एक बार पोटेंशियल एनर्जी निकाल ली तो हमें अलग से काइनेटिक एनर्जी का फॉर्मूला तो लगाना ही नहीं पड़ेगा, राइट?
बट वो इनिशियल तो अपना पोटेंशियल एनर्जी 0 थी ना यहाँ पे, क्योंकि रेस्ट पे है। अब आपको जब बी पे निकालनी है काइनेटिक एनर्जी, तो या तो आप स्पीड निकालो, इक्वेशन ऑफ मोशन लगा के, फिर हाफ mv स्क्वायर करके उसकी काइनेटिक एनर्जी निकालो, और यू कैन डू इट डायरेक्टली दैट the sum of kinetic energy and potential energy is constant. By using the conservation of mechanical energy, we use that logic. जब point A पे थे तो speed 0 थी, इसलिए kinetic energy 0. Whatever potential energy it has at point A, जब पॉइंट बी पे पहुंच गए ग्राउंड पे, दिस इज ऑन दी जस्ट रीचिंग ऑन द ग्राउंड, पोटेंशियल एनर्जी जीरो हो गई, सारी एनर्जी कन्वर्ट हो जाएगी काइनेटिक एनर्जी के फॉर्म में. दिस स्टेप यू हैव टू शो, only then your answer is correct. You cannot directly write it as same as u is equal to k. Delta u is equal to delta k, which means if potential energy is decreasing, then kinetic energy is increasing, or if potential energy is increasing, then kinetic energy will be decreasing.
सर हम सीधा ऐसे करके नहीं हो सकते k is equals to u equals to mgh, क्योंकि स्कूल में हमें ऐसे ही बताया
K is equal to
u equals to mgh.
k is equal to mgh. ये कौन सा फॉर्मूला है?
नहीं, k is equals to u equals to mgh ऐसे करके.
So why k is equal to u? Kinetic energy is equal to potential energy, not necessarily always. K is equal to c is no formula. The k is equal to u is no such formula. K plus
क्योंकि
u is
एनर्जी
constant.
कैन बी
That is
लॉस्ट
the
टू
constant.
फ्रिक्शन. हमने
K
क्वेश्चन
plus
किया था
u is
ऐसा.
constant. This is the actual concept. So when you have to write it, you have to write it that you can write it sum of kinetic plus potential is constant. This is the formula. U is equal to k. U is equal to k gives the misinterpretation that at any point potential energy is equal to kinetic energy, which is not correct. Potential energy is not equal to kinetic energy. The loss in potential energy is equal to gain in kinetic energy. Right? समझ गया ना विहान? आपने पहले भी ये डाउट पूछा था. U is equal to k is no formula. That's no concept. Sum of potential plus kinetic is constant.
Yes sir, मैं समझ गया.
Third part, what happens to the mechanical energy after the ball hits the ground and comes to rest? Mr. Okay, sorry. Just कि वो नीचे आई surface पे hit करके it comes to rest. Then what happened to its energy? The energy that it possessed वो कहाँ गई? Now this is energy conversion. जब ball नीचे floor पे hit करेगी तो कुछ आवाज भी आएगी and there will be some heat loss. थोड़ी सी ball heated up हो जाएगी. So because of its potential energy, its energy that it had stored, now that energy is converted into heat and sound. The total mechanical energy converts into heat and sound.
Sir, and depending on the strength of the material, it might also deform.
Come again?
Depending on the strength of the material, it might also deform.
But it is a metal, no? Question says metal ball. If it would have been some plastic ball, mud ball, rubber ball, then there will also be change of the shape, which is related with the potential energy. Then some part will also change into potential energy. Okay, Riddhi, question number 4. That's for you. Question number 4. The diagram shows given below shows a ski jump, a skier weighing 60 kgf stands at A, which is the top of the ski jump, which is 75 meters. He moves from A and takes off his jump at point B. At point B, he takes his jump and where the height is 15 meters. Calculate the change in gravitational potential energy of the skier between A and C, between A and B. So between A and B, the height that it descends is 75 minus 15, that's 60 meters. Riddhi,
Yes, sir.
what will be the answer to first part? I mean, formula for the first part, change in potential energy.
So it will be mgh only.
Right, it will be mgh, and h is that height that it descends, that is 75 minus 15, so that's 60, which is mass is how much?
So mass is going to be 60 kg.
G is also 10 given, so H is 60. That's 36. Okay, how do we do the second part?
So we can't express the value in just 36,000 joules.
Abida?
So we can't express the value in 36,000 joules.
This is called scientific notation. Any big number is always written in terms of order. This is called scientific notation. You can write, but a teacher can deduct half marks on this.
Okay, sir.
Usually they don't, but the big numbers or very small numbers are always expressed in terms of their order. Order is always expressed as 10 raised to power. Just say unit, tens, hundred, thousand, something like that. So you'll have to
But
give that.
why are decimals, sir? We can just do 36 into 10 raised to 3.
That's why this is a scientific notation. This you will see in class 11th.
Okay, sir.
36 into 10 to power 3 gives again a confusion of the order. Order is 3 or 4. This 10 is to power something gives the order of the magnitude.
Okay, sir.
Order you understood, na? Units, tens,
Yes, sir.
hundred,
Yes, sir.
thousand. So how unit is 10 is to power 0. Tens is 10 to the power 1. 100 means 10 is to power 2. 1000 is 10 is to power 3 and so on. So what is the order of that quantity? To determine that, to denote that, we express numbers always in terms of their scientific notation or in terms of their order. B part, Riddhi, how will you do that? 75% of the energy becomes static energy.
So we will calculate 75% of 36,000 joule, which comes out to be 27,000 joule. And then the equation formed will be 27,000 is equal to half mv squared.
Okay, now my question is why there is only 75%? Where does the rest 25% go? Shouldn't be constant. The loss in gravitational potential energy is equal to increase in kinetic energy.
Sir, I can't hear you. Your voice is cracking. Can you please repeat?
My voice is cracking. Okay. Wait. Only 75%. Why there is only 75%? Why be complete conversion of energy?
So because at point B, it is still at a particular height. At point B, it is still at a height, so there is some potential energy left.
Potential energy, but we already included that, na? Because it is the loss only. Change. This point 300 10 to the power 4 is not the potential energy at point A. This is the change in potential energy. When from A to point B we go, this is the loss in energy. Right?
Yes, sir.
Where is the 25% of the energy? There, where is the remaining 25% of the energy? I mean, what might be the 25% of the energy? Yes, Adya?
Yes, sir. I'm thinking.
That is the remaining 25% of energy. I mean, this 75% does not include the potential energy that it has already here.
Sir, could it be friction?
Yes, that is because of the friction. Because ice's surface is not necessarily perfectly smooth. So due to the friction, there might be loss of energy. So that loss of energy goes to the heat because of the friction. Ice surface, we assume that it's perfectly smooth, but that is not necessarily the case of, on the snow because it is amorphous. There will be some friction. So that can be a third part. What is the loss of energy due to friction, or what is the heat produced due to friction? Then we will be calculating the remaining 25%. Did you understood?
Yes, sir.
From point A to point B, the loss was only this. So this is the total loss of energy. If the surface would have been perfectly smooth, there is no dissipative force, then all of that energy should convert in the kinetic energy, but only 75% is changing because the remaining 25% has already some amount of, because of the friction, the some amount of energy is lost. Right, question number 5. Mr. No, Aditya. Sorry, Mr. Vikramaditya. So Vikramaditya, Vikramaditya. Okay. This is some water reservoir of the dam, which is 50-meter height. There is a turbine blade, and the water falls from this height. Now, assuming that overall efficiency is 40%, calculate the mass of water which must flow through the turbine per each second to produce a power output of 1 megawatt.
सर ये ओवरऑल एफिशिएंसी का क्या होती है?
बता रहा हूँ efficiency का मतलब क्या है. इस potential energy का कितना part यहाँ पे kinetic energy के form में convert होगा. Like in the previous case,
तो
we
40
saw
by
that there is
100 of mgh हो जाएगा.
right. So that means efficiency 40% means only 40% of potential energy. 40% of potential energy stored at maximum height at 50 meter is converted in the kinetic energy. When it hits the turbine. ना कबीर समझ आ रहा है ये लॉजिक?
ऐसा थोड़ा थोड़ा.
यार थोड़ा थोड़ा मजा नहीं आती. फिर पूछो जो पार्ट क्लियर नहीं है, दैट यू हैव टू आस्क. देखो पिछले वाले केस में क्या था, जितनी स्केयर के पास एनर्जी थी एट द टॉप मोस्ट पॉइंट, वो सारी की सारी बी पे नहीं आई. 25% लॉस हो गई बिकॉज ऑफ द फ्रिक्शन. अभी क्या हो रहा है, दिस इज द वाटर स्टोर्ड इन द डैम रिजर्वायर, और उसको वहां से फिर नीचे फॉल करते हैं. रास्ते में कुछ एयर फ्रिक्शन होगा, देयर माइट बी सम अदर रीजन, दैट ओनली 40% ऑफ दैट एनर्जी गोज टू द टर्बाइन. अब टर्बाइन को प्रोड्यूस करनी है पावर कितनी? The turbine is producing 1 million watt or 1 megawatt, that is 10 to the power 6 watt. In how much time? Per second. So total energy output is 10 to the power 6 watt. Energy unit power 10 to the power 6 joule per second.
Sir, why can't we just leave the answer in megawatts?
No, because mega is not the exact standard unit. 40% of mgh converts into the output power. Input is like mgh, where m is mass falling per unit time or in 1 second. Because when it is power, power means energy per unit time. So here m is the mass of water flowing per second. That's why it will be energy on the other side per unit second. Energy per second is power. So this output power is 10 to the power 6, 40 by 100. M हमें calculate करना है, G को 10 ले लेते हैं. H is simply solve this for M. Method clear? Kabir?
सर ये आपने 40/100 into mgh equals to उसके आगे क्या लिखा है, वो पावर है कि
Output power, output power. This is the ये ऊपर लिखा हुआ ना energy output, that is P out. Output power कितना मिल रहा है हमें टरबाइन से? Total power output. इसको short form में लिख दिया मैंने. P out stands for, this is the output. Input क्या है? This potential energy. Potential energy is stored where?
सर क्लियर है.
अरे आंसर आ गया ना, आंसर सॉल्व करो मुझको. फिर तो ठीक है. फाइंड द आंसर.
1000 आ रहा है.
सर आ गया आंसर
आ रहा है कितना है एम?
5000 kg.
5000.
5000 kg. यहाँ पे पोटेंशियल एनर्जी स्टोर थी. टोटल पोटेंशियल एनर्जी का 40% कन्वर्ट हो रहा है काइनेटिक एनर्जी में. जितना कन्वर्ट हो रहा है उतने के बराबर ही इलेक्ट्रिसिटी टरबाइन टरबाइन ब्लेड. Only 40% of potential energy into electricity. That electricity is given as 10 to the power 6. Kabir? 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 Mr. Kabir? कहाँ गए? Very nice. ज्यादा क्वेश्चन पूछो तो लोग गायब हो जाते हैं. Okay, one last question. Okay. This is for you. The bob of simple pendulum is imparted a velocity of 5 meters per second when it is at the lowest point. So when it is at the lowest point, it imparts a velocity. It is imparted a velocity of 5 meters per second. Now, to what maximum vertical height will it rise on the reaching the extreme position if 60% is lost? If 60% is lost in converting in overcoming the friction. So which means at the maximum height, only the 40% of energy will convert in the potential energy. 60% of energy is lost, so 40% of the energy given goes to potential energy. तेजस्वी ये क्वेश्चन समझ आ रहे हैं?
यस सर समझ आ रहा है. हमें यहाँ पे सिर्फ दो ही चीजें दी है. इन्होंने एक ये बता रखा है कि 40% कन्वर्ट हो रहा है और एक उन्होंने हमें यू दे रखा है विच इज 5. पर आई डोंट नो कि ये निकलेगा कैसे इसका आंसर. मुझे ये समझ नहीं आ रहा.
Mass is, suppose we assume mass is m. 60% of kinetic energy is lost in friction, so that means only 40% energy converts into potential energy at maximum height. If there is no loss, then all of the energy given will convert. So 40% of total kinetic energy given at the lowest point will be equal to the potential energy acquired at maximum height. M gone. Speed to given है 5 meter per second. We'll substitute U as 5. So in this case, we are not applying energy conservation. We are using this information given that total energy 40% only converts in the form of potential energy. Right? Okay, if you want to revise, you can revise. So this chapter is completed from the book. I mean, your Serena book is done. Now we will do some extra questions in next class. But there are two worksheet-based tests, class test. One is 20 minutes. So one I am giving from the last also, the last chapter that was
सर अभी
circular.
भी होगा क्या, मतलब अभी टेस्ट होगा?
हाँ बेटा अभी होगा right now. Yes, one is from center of gravity. सेंटर ऑफ ग्रेविटी का भी मैंने वर्कशीट बेस्ड टेस्ट नहीं लिया था आपका बिकॉज
हाँ जी हाँ, तो
हाँ?
अभी 2 टेस्ट होंगे।
नहीं मैं एक ही दे देता हूँ, एक ही कर लो कोई नहीं।
ओके सर।
ओके एक तो फोर्स का भी बचा हुआ है, वी डिड सम ओनली फ्यू क्वेश्चंस। ओके कोई बात नहीं। अभी सेंटर ऑफ ग्रेविटी का देना है या वर्क का देना है, जल्दी बताओ। बोथ यू हैव टू गिव व्हिचएवर यू वांट फर्स्ट।
सर
यस
जो आपकी मर्जी हो सर।
यस वो है। मैं कहता हूँ सर आप सेंटर ऑफ ग्रेविटी का रेट अपनी वर्क और उसका तो हम कल भी लेंगे।
ओके सो यू हैव टू कीप योर कैमरा ऑन। आई एम शेयरिंग दिस ऑन द ग्रुप। This is for center of gravity, worksheet number 8. 7 is
सर
will be
आप
given
ये
to the
जूम के चैट वाले सेक्शन पे अपलोड कर सकते हो क्या?
जूम के चैट वाले सेक्शन पे अपलोड कर सकता हूँ मैं। या मैं इसको स्क्रीन पर भी दिखा सकता। This is worksheet number 8. And if you want to chat, see here.
सर आप स्क्रीन शेयर ही कर दो चलो।
But yes, I can show this here on the WhatsApp also. So called it, but no, it's not for 30 minutes. Even yes, all of you got this worksheet.
Yes, sir. I've received the worksheet.
You don't need to write the question again, just write the question number, worksheet number. In class, we used to do this in hard copy, but okay.
सर आप थोड़ा
Yeah,
ऊपर कर सकते हो.
बेटा.
हाँ ये ऐसे ही रखो बस.
हाँ मैं question 1 2 yes. फोर्स की कुछ वर्कशीट बची थी, वो मैं होमवर्क में आपको दे रहा हूँ. यू हैव टू सबमिट इट टू मी और षष्ठी मैम. जस्ट अ सेकंड.
How much time do we have?
Yes, Vihan, you said something.
So how much time?
How much time? 30 minutes by 2:10. I mean, this is 2-page
Okay.
worksheet.
सर जैसे क्वेश्चन 4 में है तो इसमें हमें बस लिखना है या फिर ड्रॉ करके भी दिखाना है.
Both draw in diagram also and show in, I mean, write also verbally
Okay,
what
sir.
that point is called.
सर आप थोड़ा नीचे स्क्रॉल कर सकते हो.
Yes, beta.
सर आई वाज सेइंग आप थोड़ा नीचे स्क्रॉल कर सकते हो.
Bilkul. This is a 6-7 in first page. And you have to write a decent explanation. I mean, in the scientific terms, not too much, but at least explaining the logic behind it.
सर हमसे क्वेश्चन 4 में भी सेम चीज पूछी है, क्वेश्चन 6 के बी पार्ट में भी सेम चीज पूछी है।
हाँ वो रिपीटेड हो गया, कोई बात नहीं, चलेगा। दैट वाज द ट्रायंगुलर लैमिना एंड ठीक है, 1 बोनस मार्क मिल गए एक ही क्वेश्चन को 2 बार लिखने के। Actually, these questions are mostly the previous year board questions. तो इसलिए वो उसी लैंग्वेज में वैसे कॉपीड है।
सर आप दूसरी वर्कशीट में स्विच कर सकते हो? सर 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 आप नेक्स्ट पेज पे जा सकते हो? थैंक यू सर।
यस बेटा, जिसका हो जाए सबमिट कर देना और कैन लीव.
Sir, I'm not getting some of the questions.
Kabir,
Yes, sir.
which question?
So like some of them I'm not understanding them.
Which question? बताओ तो मैं hint दूं अगर.
Like I can understand them. I don't remember the word to word answers. Like I don't know what to write.
So you should have prepared. Chapter is completed. You have already given the test.
Yes, sir.
Okay. No problem. Write those answers which you know.
Okay, sir.
But you should prepare now. I mean, this is not
So
a
should
right.
I prepare and then send it to you?
No, you have to send this worksheet right now. Not. I will give you more for the homework. I am sending
Sir,
more worksheet.
question
Yes.
11 last है, right?
11 is the last question. Yes.
Yes, sir. मेरा हो गया.
और जिसका भी हो जाए मुझे send कर देना. Can send and leave. और श्रेय अभी क्लास में करना है, क्लास के 1 घंटे बाद नहीं. You usually take more time to submit.
Okay, sir.
सर मैंने कर लिया है बट मेरे को सबमिट करने में टाइम लगेगा.
क्यों?
क्योंकि मैं कहीं और हूँ और यहाँ से मैं अपना व्हाट्सएप एक्सेस नहीं कर सकता. अगर मैं फोटो खींच भी लूंगा तो मैं आपको
वॉइस
भेज
बहुत
दूंगा.
लो आ रही, फिर से बोलना.
सर मैं कहीं और हूँ ना तो मैं यहाँ से अपना व्हाट्सएप एक्सेस नहीं कर पाऊंगा. तो मैं अगर भेज भी लूंगा उसकी फोटो तो मैं
मेल
आपको,
कर पाओगे?
हाँ मैं आपको मेल कर दूंगा. यस, मैं आपको मेल कर दूंगा.
मेल कर दो. My email ID is
ओके सर, मैं आपको यहाँ पे मेल कर दूंगा.
okay. Done.
Sir, last question का last sub part.
सर मैं आपको भी मेल कर दूंगा.
So shall I send the worksheet to you?
Yes. Or you can send it to Shasti ma'am.
सर,
Yes.
सर चैट पे अपना नंबर लिख सकते हो, मैं दूसरे फोन पे से सेंड कर लूंगा, उसमें पीडीएफ फॉर्म में हो जाता है.
षष्ठी मैम का नंबर ना, षष्ठी मैम को कर दो, कोई प्रॉब्लम नहीं. मुझे भी उन्हीं को करना है. You have षष्ठी मैम नंबर ना, आप उनको कर दो.
ओके सर.
Tejas, we done?
So second last question, we're almost done.
Beta Vikramaditya, can you speak now? Your mic is working. Vikramaditya? Pradeep, write your name, or better you can convert this in the PDF.
Okay, sir.
Yeah, convert in PDF, write your name, date, and the DPP topic also.
So do we mail it, send it on WhatsApp?
But if you can WhatsApp, that's better. If you don't have access to WhatsApp, then
Sir, I've sent it.
सर मैं आपको किसी और की मेल आईडी से भेज दूँ चलेगा?
अरे किसी से भी भेजो यार, मुझे क्या फर्क पड़ता है.
ओके सर.
But convert it into PDF, that's better because pages gets sometimes lost.
Sir, I've sent the my work as a PDF.
Okay, okay then. Right. Tejasvi, Shrey, Vikramaditya,
सर मैं सेंड कर रहा हूँ.
आप सेंड कर रहे हो, ठीक है.
So मैं भी send कर रही हूँ.
Okay, okay then. Fine.
Sir, if I've sent, may I leave?
Sir, you can leave. Yeah.
सर मैंने भी
Thank you, sir.
सेंड कर
Bye.
दिया.
You have mailed me.
यस सर.
Let me check. Yes. यार ये email मत भेजा करो, PDF बना के. Can you convert it into PDF, Ihan?
Sir, I won't be able to convert it into PDF, sir.
Okay.
So मैंने भी आपको भेज दिया. Can I leave?
Just a second.
सर मैं आपको फिर जब मैं अपने घर से घर जाऊंगा तब मैं आपको पीडीएफ बना के भी भेज दूंगा.
ठीक है कबीर, I got your.
Sorry, sir, I'll give it again, sir.
Sir, can I leave?
all of you can leave. Adya, you haven't sent. Shrey, I haven't received.
Thank you
So
so
send to
much.
the ma'ams. Okay. Bye.
Bye, sir.